Welcome to another video explaining the universe using the particle model. Well, today's video is a step away from what I've been doing in terms of the senses. I will continue with that shortly, but I found this question and answer sequence that Quora puts out, Quora.com, I guess it is. And I'm suggesting that that when people ask Quora questions, that maybe they ought to be asking Particle Guru the questions, not Quora. Today was a question about the acceleration of a photon. A Quora subscriber asks, how do you disprove that light speed travel is possible if you know it takes this long number seconds for a photon to accelerate up to light speed from zero from its photon generator? Well, Quora restates the question. How do you disprove that light speed travel is possible if you know that it takes 23,321 thousandths of a second for a photon to get up to light speed from zero from its photon generator? He changes the number. He obviously didn't agree with the number, and he changed it into 23 thousandths. And if this is 23 thousandths, then this is actually 23 seconds. So he's kind of highlighting a problem with the time that the person asked about how long it takes to get up to speed. So he starts his answer. He says, hey, dude, if your light bulb takes 23 seconds to get from turn on to start giving off light, there must be something seriously wrong with your lamp. More importantly, if it took the photons even 1/1000th of a second to do so, that would still mean for the first few hundred kilometers, the light would be moving far less than its final speed. If you're not moving at the speed of light, then you can't see it. Your eye is tuned to see peaks of the light at a certain interval. And he says this poses two problems. First, explaining what would still be adding energy to the photon once it's already 700 kilometers from its source. In other words, the light has to get up to speed c, so something has to keep accelerating it through the 23-second process and beyond. Second, we don't see a problem. Why we don't see a problem with indoor lighting or television screens with vastly slower photons, which would be much less energetic due to their slower speed. Okay, light moving at slower speed. So you turn on the light, you couldn't see the light for however many seconds, 23 seconds before. And then, of course, light bulbs turn on instantly. Well, here's Quora's really the final answer. So far, every attempt at measuring how long it takes a photon to get up to light speed has come up with 0 time. Well, I really didn't take the time to look and find where these experiments were that were attempting to measure this. I don't know. But obviously, Quora is saying, well, their answer is it's 0. This is my answer to response to that. 0 to c in 0 seconds is infinite acceleration, and that's not possible. But Quora challenges the subscriber. He says, so it becomes reasonable to ask how you know it takes some measurable amount of time, the 23 seconds. Feel free to share your experimental results as a physicist who comes up with a reproducible measurement of this will certainly be winning a Nobel Prize. Okay, we got a Nobel Prize in the offering. Okay, I'm going to go back to my common answer about light, about their answer about light, where a particle hits an atom, the electron jumps up. When it falls down, it releases energy in the form of a photon. Okay, well, the photon is energy. So according to them, the photon is a packet of energy with wave-like properties. Where does it get its wave-like properties? Based on the amount of energy, this energy gap that falls down, that amount of energy times equals Planck's constant times the frequency. So frequency is the energy divided by Planck's constant. That determines the frequency of. So where does the force of acceleration even come from? No explanation. Doesn't make sense that you have infinite acceleration from 0 to speed c. But this is how they say it's generated. And they say it takes 0 time to go from here. Once the electron hits this level, all the energy is released. The photon is magically there and it's moving at speed c. Okay, well, this is from Wikipedia about the galvanic cell, and we have a zinc electrode interacting with an electrolyte, releasing 2 electrons. I claim this is happening mechanically as the electrolyte and the zinc atoms are vibrating against each other and knocking these loose. And of course, they were orbitals, whether it's in the electrolyte or in the zinc, they were orbitals, and orbitals move at a high speed. So they're already moving at a high speed. These are moving at a high speed. The same thing's happening over here, although this isn't the way this, they have this equation reversed. They say this plus this, electrons are captured in the copper and make copper. And I'm saying, I don't think so. Yeah, my explanation is that copper interacting with the electrolyte, and it also releases 2 electrons. Let me explain why. There is a rating of all different metals that you could use for electrodes, an electrical rating, or electrical potential, and they say that zinc has the electrical potential of 0.76 volts. Copper has the electrical potential of 0.34 volts. And basically what's happening here is a release of twice as many. The voltage is twice as many, but the equations only show 2 here and 2 here. It implies that there's twice as many interactions here. For every 1 interaction here, there's 2 here. That would explain this voltage difference. And by the way, the sum of those 2 give you the standard 1.1 volt wet cell that that they talk about in wet cells. Go back to the particle model answer. Always start with how many G1s are coming into the positive end of the battery. That's where I start. The battery adds. In this case, it's going to add the equivalent of 0.34 volts. And that's in the form of adding G1 particles. So you got whatever number of G1 particles coming over here, and this is going to add 0.7. It's going to add twice as many. The net result is you got a minus 1.1 volts coming out here, or that many G1s entering the light bulb. Yes, in the particle model, these G1 particles hit the atoms of the filament, cause them to vibrate. And as this G1 flow passes through the filament, the vibrating atoms push out peaks, peak, peak, peak at the rate of the vibrating atom, and that's how it's generated. They're released at C. They're released at C here. They're released at C here. They're moving at C. And when they get pushed out, they're moving at C already. That's the explanation. And that's not the way you'll read it here. That's the way I'm saying it happens. So you got, if you had none coming in here, you got for every one G1 particle here, you got 2 here, which sets up this 1.1 volt. You get this many added. You lose the same number through the light bulb. You're going to lose 1.1 volt across the light bulb. Starts at C, and it's released at C. So the conclusion is Quora's answer indicates they have no, what they have is no answer for infinite acceleration. They don't have an explanation. They just say it happens. Particle's answer is that the G1 is already moving at speed c, therefore there is no need for infinite acceleration. Yeah, we don't have an answer either, but we're not claiming that it goes from 0 to speed c in 0 time. Sorry, nobody gets a Nobel Prize. My name is Bob D. Hilster, and I am your particle model guru. Tune in next time when I explain more of the universe using the particle model. Thank you for your attention.